Okay, good morning class. So today we're looking at the last part of the real numbers. So two things we're looking at today is basically the classification of our number system as well as plotting an irrational number on the number line. So this is the shorter one of the two that I need to explain, so I'm going to start with this. So irrational numbers like the square root of 2, the square root of 26, the square root. People, where did you see these things? And what did we call this last year? We called it surds, yes. Why? Because the square root of that number is not going to be a natural number. Remember, it's not a whole number. Okay? And when did we use this? Where did you see this? Under which topic? Pythagoras. Yes, well done. It looks like you guys remembered well. No, the holidays seem to be not good for you guys. Okay. But we used this when we were doing the Pythagorean theorem. Now there's two ways to answer this question here. The question says, represent the square root of 26 on the number line. Okay? Represent this on the number line. However, as I said, there's two ways of doing it. Just copy this. The one is by using exactly Pythagoras, the Pythagorean theorem, or the way I'm going to show you now. And I prefer this way here. So I don't like to think too much. And many of you don't like to think at all. No? So let's look at the square root of 26. Now, what we do is we say, okay, the square root of 26, to represent this on the number line, we need to know which two numbers or two natural numbers does 26 lie between, in other words. Okay. So, if we're looking at perfect squares, or perfect square roots, what is it? 1 squared is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6. What do you notice? That 26 is lying, the square root of 26 is lying between those two numbers. Not so. So if I should answer this, and then to the left of the root of 26 is going to be the square root of 25, and to the right, or bigger than the square root of 6, the perfect square is going to be the square root of 36. What's the square root of 25? 5. The square root of 36? 6. So in other words, the square root of 26 is larger than 5 but less than 6. Okay? But remember the question was to write this on a number line, not so. So what do? We just simply put there number line 5, 6, and of course the square root of. Do you guys understand? So do another one. I made. You guys still saying this. Okay, so you guys mean to say you guys don't understand. We just want to make sure with another sum. Right, let's see what the textbook has as a. Right, the square root of 136. This is from the textbook, the square root of 136. So of course I'm not going to start again by 1 and all of those things. Let's just extend this here. What is then the next perfect square after this? Square root of 7, which is 49. Square root of 8 is 64. The square of 9 is 81. Square root of 10 squared 100. 11 squared 121. 12 squared 144. Okay, there we were over now. So what does that mean? It lies between these two. No? Now, do we have to list all these numbers here? No. I'm just showing you what your thinking process should be. You guys understand? Am I moving too fast? Okay. So that means to say to the left of the square root of 136 is what? 121. The square root of 121. And to the right of 136? 144. So which means to say the square root of 121 is 11. The square root of 144 is? So that means to say the square root of 136 is larger than 11 but less than 12. So if I represent this on a number line, which numbers should I have? 11, 12, and of course the square root of 136 lies between them. Do you guys understand? Yes. Can I do one more? Yes. Okay. Let's use a negative number. Life is not going to always be this easy, okay? So let's go. Square negative square root of 63. Okay. So between which two perfect squares are 63 lah? So this you're saying 8, which is 64, square root of 64, and 7, square root of 49. But remember, it's negatives, not so. So let's see, it's going to be negative 8 and negative 7. You all agree with that? Okay, so to the right, there's the smaller one, is negative root 64, and that way is the larger one, of course, which is negative root 49. So that's going to be negative 8 and negative. You all agree negative 8 is smaller than negative 7? Yes. On the number line, remember here? Yes. Now we're working in the reverse. Okay. So in other words, it's going to be negative 60. The square root of 63 in the negative. On your number line, it will be represented as negative 8, negative 7, or negative square root 60. Do you guys understand? Yes. Any confusion? Don't say no, and then comes to the exams, then you guys pull up your funny tricks, okay? So something to note at this point is that when they ask you to represent this on the number line, okay? This is where the marks will be awarded. Okay, so you're thinking of all this stuff. You don't have to show all of this here. Okay? This is where we will give you your 2 marks. Okay? So if you want to write all that squares on the side, you want to write this, this you don't have to write. But this is what we need to see. Okay? What do you miss? Thank you, Mr. E. Okay, any confusion? No. No. So now, let's now. We are now, no? Not 11 yet. So now we're going to look at rational and irrational numbers, okay? And real and all of those things. So irrational numbers. So people, you guys remember what natural numbers are? You all remember what natural numbers are? What are natural numbers? Right? Yes, I'm hearing the right thing here and there. Natural numbers starts at 1, 2, 3, 4, 5, and so on. Not so. Goes all the way to infinity. We dealt with that in grade 8. Then we spoke about whole numbers. No? Whole number starts at 0, 1, 2, 3, 4, all the way to infinity. Then we spoke about integers, which is negative and positive whole numbers, not so. So 0, 1, 2, 3, all the way to infinity, and negative 1, negative 2, negative 3, all the way to negative infinity. Not so. Right. Now we're going to introduce what we call rational numbers. Okay. What is going on today? I'm not very good at this stuff. Right, here we go. So, irrational numbers. Oh, we spoke about rational numbers last year as well. Yes. Remember that one topic we spent a lot of time on? Which was dealing with fractions, no? So we said there are 3 categories in which those rational numbers fall. 3 categories, okay? So we got rational. And rational numbers are numbers that can be written as fractions. Yes. So now we can, yes, decimal. Decimal, there's two decimal fractions, which is decimal, recurring decimal, which we just did now. What did you notice about the recurring numbers? It can be written as fractions, not so? And the fractions could be written as recurring numbers, recurring decimals, not so? So, recurring decimals also forms part of the rational numbers. And the other one was terminating decimals. So, irrational numbers are what? Numbers that can be written as fractions, recurring numbers, and terminating decimal fractions. Okay? So, it's fractions, terminating decimal numbers, and recurring decimal numbers. Okay? So, now we're looking at irrational numbers. Irrational numbers are all infinite non-recurring decimal numbers are irrational. So, what does that mean? That means to say, can an irrational number be written as a fraction? No. Can an irrational number be a terminating decimal? No. Can an irrational number be a recurring number? No. So the number can either be rational or irrational or none. An example of that would be, what is 5 divided by 0? You guys, 5 divided by 0. How many times can 0 be divided into 5? 5, no? And 5 over 1, or 5 divided by 1? Also 5. Let's check. 5 divided by 0. Error. It's an error, not so. So, error means to say it is impossible to divide 5 by 0. Not so. So, is that rational? Because it's written as a fraction. Is that rational? No. So, the answer is non-existent. Is that an irrational number? Okay, what did we say? What are irrational numbers? Numbers that cannot be written as a fraction? It does not terminate, which means to say it doesn't end. And it does not recur. However, the number is still real. You guys understand? So, is 0 divided by 5, is that real? Can we do that calculation? No. So, it's not real. So, is that rational? No. Is it irrational? No. It is none of it. That is why I say a number can either be rational or irrational or none. Okay? But it can't be rational and irrational at the same time. You guys understand? Alright. So here, the square root of a positive non-square number. And what do we call this? A surd. Remember we said that's a surd? And the cube root of a non-cube number is irrational. Examples, irrational numbers is 0, 438, 1, 4, 9, 7, and the number carries on. Can you see how this dot means to say? It carries on. Does this follow a pattern? Is this saying 4, 3, 8, 1, 4, 3, 8, 1, 4, 3, 8? Is that what it's saying? No. So this is considered as an irrational number. You guys understand? Pi. Remember we spoke about pi last year when we did circles? And then we let pi equal to 22 over 7. Not so? It's actually approximately 22 over 7. Which is all, it could be approximately 3,14. One of those. Because if you look at this pi itself on the calculator, just press shift pi. Whoops. Shift pi. Press SD, you see pi in its form is 3,14,159. 2654. And of course this number carries on. But why doesn't this calculator carry it on? Because it's only a 10-digit display or 12-digit display. Can you see it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-digit display. But if you plug that pi in a calculator, you will see that the number actually carries on till infinity. Can you see that, people? Will carry on forever. So pi in its original form is what? An irrational number. You guys understand? But what do you notice? 22 over 7. What's 22 over 7? Rational or irrational? 22 over 7. Is it not a fraction? So this is actually rational. 3,14. Terminating decimal. So what is that? Rational. So why do you think we let that irrational number be equal to approximately irrational numbers? Is to make calculation easy for us. You guys understand? Like 3,14. You see that's a terminating 3, you see that is a rounded off answer to the original pi. Can you see that? We are going to go 22 over 7. 22 over 7. That is 3,14, and there's a 285, but this is 159. Can you see that, people? So even from there you can see that fraction is not far off from, but is of course not exactly the same as that. Okay. So here it says pi is 22 over 7 is not only an approximate value, and therefore it is also irrational. Then we say pi is 3,1415. There we got that, and it carries on. The square root of 10, again, the square root of 10, it's a third, and you see it's the 3,1627. 16227766, and the number carries on. Is this a recurring number? No. So again, it's irrational. All thirds are irrational numbers. Okay. So that's that. The cube root of 20. Again, the cube root of 20 is 2,7144,17617. So is that following a pattern? No. Again, an example of irrational numbers. Okay. All the decimal numbers in the examples above of infinite, they are non-recurring. Like the square root of 10 is 3,16, can be rounded to two decimal places. Therefore, square root of 10, irrational. The square root of 5, we spoke about that. Okay, now if you're looking at 5 squared, the square root of 5 squared. People, what does 5 squared mean? The square root of 5 squared mean? That's what you say. It's going to be the square root of 5 times the square root of 5, not so? Which is the square root of 25, which is 5. So the question we should ask ourselves, is this solution rational or irrational? Rational. It can be written as a fraction, not so? How? 5 over 1. So that is rational. So the original sum is also rational. Make sense? So if we're looking at, okay, let's carry on. So the summary, rational numbers or numbers can be written as fractions. There is a fraction, that can be written as a fraction. That is a recurring number, can be written as fraction, terminating is fraction. Square root of 25 is 5. The square root of 100 is 10. The square root of 49 is 7. Can you see here? The square root of 100 over 49 is going to be 10 over 7. Is this 10 over 7 rational or irrational? Rational. Which makes the square root of 100 over 49 rational. Makes sense, people? Right, so let's carry on. And here's further more examples of rational numbers. What's the square root of 10 squared? 10. What's the cube root of 8? 2. What's the square root of 2 squared? 2. So there's going to be 2 plus 2, which is 4. So this is also rational. Can you see that, people? And there's many more other rational numbers out there. So remember, all these natural numbers can be written as a fraction, not so. We just put it over 1. Then it becomes a natural number, which is a rational number. A whole number is a rational number, integers are rational numbers. Okay? Because it all can be written as fractions.
So is 0 a rational number?
Yes, because it can be written as 0 over 1. Okay, so 0 is also a rational number. Okay, irrational numbers, the square root of 3, which is a third, 213, 497, and number carries on, no pattern for you to follow there. So it's irrational, pi, irrational. Now 5 pi. 5 pi. What do you think this answer would be? Rational or irrational? Irrational. That of course is 5 pi. Shift and standard to decimal. Can you see that? Not following a pattern there. Well, what would 5 pi over 2 pi be? Rational or irrational? Rational, yes. Why? Pi's cancel, leaves you with 5 over 2. So this is actually a rational number. Can you see that? If you're looking at the square root of 2, rational or irrational? Sorry? Irrational. But if I divide that again by square root of 2, what would that answer be? 1, which is rational. You understand? So it's not only about the number as it's given to you, it is what it simplifies into. Does it make sense? Okay. Am I talking a lot? So for 5 pi, the cube root of 9 is also an irrational number. Rational plus irrational numbers, putting it together forms real numbers. So if the number is a natural number, it's real. If it's irrational, it's real. It exists. If it's rational, it's real. If it's an integer, it's real. As long as a number can be represented, it doesn't give us an error, then it's a real number. You guys understand? You okay, Michael? Sorry? What's he saying? Falling asleep? Yeah. Have a sleep or something. Okay. Divide by 0, we spoke about that. If you divide anything by 0, it is non-real to us. Not so. It is undefined. So we'll talk about more undefined later on. Okay. So a number is real or non-real. But for now, here we'll see 1 divided by 0 is undefined. But 0 divided by 1 is 0. Okay, so we're looking at real and irrational. Real and irrational then. Real and irrational. Okay, so now we're going to look at, okay, if you're looking at 2 plus the square root of 3. If you're looking at 2 plus the square root of 3, what is this? Is that rational or irrational? 2. It is rational. The square root of 3, rational or irrational? Irrational. So rational plus irrational will always be irrational. Okay. Also irrational divided by rational is irrational. Okay, unless the two irrational values cancel out as I showed you earlier. This is irrational and this is rational, sorry. So this answer will be rational or irrational? Irrational again. Okay. I feel like I'm talking a lot. So what I'm going to do now is, and this is how we're going to give it to you in your exam. Okay. It will be in a table form like this. Okay. Let's take this out here. It will be in a table format like as we have here. Okay. So the square root of 1 over 7. 1 over 7. Okay. So is 1 over 7 a natural number? Is it a natural number? No. Is it a whole number? No. Is it an integer? No. Is it rational? Yes. Is it irrational? No. Is it real? You guys understand? So what I'm going to do is I'm going to pause the video. I'm going to give you a chance to do these 3 now, okay? And then we will do it together in the video. Alright. Right, we're back. Go for it, Michael. Negative square root 3. So it's not a natural, not the whole. Is it an integer?
Yes.
Yes. Is it rational? Yes. Is it irrational? No. Is it real? Yes. Well done. Square root of 9 over 16. What does that simplify to be? 3 over 4. So we're going to test or tick the appropriate box with regards to 3 over 4. Guys understand? So is 3 over 4 natural, Michael? No? Is it a whole number? Is it an integer? No? Is it a rational number? Yes? Is it irrational? No? Is it real? Yes. Well done. Negative cube root of 8 is what? Negative 2. So we're basing our solution on negative 2 now. You guys understand? So is that natural, Michael? No. Is it a whole number? No. Is it an integer? Yes. Is it natural? Rational? Yes. Is it irrational? No. Is it real? Okay, so what I'm going to do is I'm going to pause the video again. But now we're going to answer these 5. Okay, 7. We'll answer these 7 now. Okay. So is that number natural? No. Is it a whole number? No. Is it an integer? No. Because I remember we just worked it out now, the square root of negative 3. Square root of negative 3. It's non-real. So it's not an integer. Is it rational? No. The number doesn't exist to us. How can it be written a fraction recurring or terminating decimal? Is it an irrational number? No. Is it a real number? No. So if it's none of these, how can it be real? Okay, so let's pause here a bit. No, it just pause. Alright, so let's look at the next 4 quickly. So the square root of 2 is what? The square root of 8, sorry. The cube root of 8 is 2. So is that natural?
Yes.
This category? Yes. 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 No? Yes. 1 over 6. Natural? No. Whole? Integer? Rational? Irrational? Real? 4. Is it natural?
Yes.
Is it whole? Integer? Rational? Irrational? Real? Now, the square root of 3 squared is what? 3. So we test, we're basing our answer on 3. Is it natural? Is it whole? Is it an integer? Is it rational? Is it irrational? Is it real? Right. Some of you are getting the hang of it. There's the next one, the next categories. No, the next numbers. I'll pause the video again. Let's wrap this up quickly. The cube root of 9. So you say that is irrational, not so? So that's a third, the cube root. So to get the cube root, you please shift. And the button, as you can see, it's in yellow there. So to activate any yellow key, please shift on the calculator. If you shift the button, become the cube root of 9. So as you can see, it is irrational. So the number, of course, is irrational. Would it be real? Yes. So there's none of those. The terminating decimal. What type of number is that? Rational and real. None of those there. A recurring number. Can be written as a fraction? Yes. So that is rational and real, and none of the others. Square root of 10, that's a third, not so? Square root of 10 is a third. Yep. So that is irrational and real. So it's no, 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 and no. 2 root 10, that's also a third. You see that, people? That's also irrational. And real. Square root of negative 2? Sorry? None exists, doesn't exist us. So it's none of these. Okay. 5, 1, 8, 9, 7 and number carries on. Is this following a pattern? Now, how do we know it would be following a pattern if there's a dot on top thing? Okay. So, what type of number is this? Irrational. Irrational, real, and none of these. Okay, you guys understand? Any confusion? No? So let's just do the last
Apologies
bit
for
off.
the interruption. Jody Jacobs, can you please report to the office?
Okay.
Jody Jacobs, please report to the office. She's 8A.
Okay. So negative 2 and a third. What type of number is that? Fraction. So what type of, in which category would that fall? Rational and real. So it's none of these here. 9 pi. Irrational. And real. Not so. None of those then. Negative 3. Integers. Is it rational? Yes. Is it irrational? Is it real? Is it whole numbers? Is it natural? And there we go. Okay. So that basically brings us to the end of our first chapter, which is real numbers. Okay.